Hello, we're going to look at chain rule, an example of chain rule. So this is a question that has shown up in the worksheet for 2.4, I guess. And this is the question. Question 4, g of x is 6x plus 5 cubed multiply 3x minus 1 fourth. And we want to find its derivative or differentiate this function. So this is a product, but each one of them is not easy to do. So we'll look at how we can use chain rule to do this. So first of all, because this is also g, I want to just change it to y. And then we have two functions here. One is, products of x, fx plus 5 cubed. I call it f, and I call this part g. And we recall if we have y prime, that would equal to f times g prime plus fixed g and times the other's derivative. Okay, so we'll just follow this. And also the other things we want to know is the general power rule. If I have y equal to h of x to the n, then y prime would equal to n, or look like h, times h of x to the n minus 1. But then I have to also change it with h prime of x. Okay, so let's see. So I'm going to do this y prime now. Y prime would equal to 6x plus 5 is f, so I'm going to fix f. 6x plus 5 to the cube. This I don't change. But I'm going to do the derivative of 3x minus 1 to the fourth because that's g and I want to do g prime. Multiply, what is the derivative of 3x minus 1 to the fourth? Oh, I can use the general power rule. So the power of this group is 4, so I multiply by 4. And then I say 3x minus 1. The exponent would be 4 minus 1, so it would be 3. And then I need to multiply it with h prime of x, so the derivative of 3x minus 1, that's actually just 3. So that's the first group, and then g times f of prime. G is 3x minus 1 to the fourth. F prime is this group, okay? So I have to do the general power rule again, 3 times 6x plus 5 to the power 3 minus 1 is second, and then the derivative of 6x plus 5 is 6. So, and then we will just multiply them. So see, I have 3 and 4 being the coefficient, so I multiply 12. And then the first group is 6x plus 5 cubed. The second group is 3x minus 1 cubed also. The second group of terms is 18 because 3 times 6 is 18. And then I have two products, 3x minus 1 to the fourth and 6x plus 5 second. Now, we could just leave it that way, but it would be nice if you can factor it because they're a common factor among them. So 6x plus 5 to the cube. For this group, that's 6x plus 5 squared. So the common factor would be 6x plus 5 squared, the lowest exponent. What about the constant term? 12 and 18's common factor is 6. And then we have 6x plus 5 squared, which is the common factor. What about 3x minus 1? This exponent is 3. This exponent is 4, so the common factor is 3x minus 1 cubed, the lower one. Now we factor those out, and then the first would be, okay, I take away 6, so this would be 2. I take away 6x plus 5 squared, I have one more 6x plus 5. And then I take away 3x minus 1 already, so that's no more. Or actually just 1. Plus, if I take away 6, 18 becomes 3. And then 3x minus 1, I take away only a third. So I would have 3x minus 1. And then for 6x plus 5, the whole 6x plus 5 square was taken out, so that's no more. So I factored it, and then the next step is to combine like terms in this group. 6x plus 5 square, 3x minus 1 cube, just repeat copying them. And then so that would be 12x plus 10 because of to distribute, plus 9x minus 3. This combined as 21x and then plus 7. So the answer is 6x plus 5 square, 3x minus 1 cube, and then 21x. 10 minus 3 is 7 plus 7. And then I noticed that 21x plus 7 actually has a common factor of 7, so I can take it out. So it'll be 42. Multiply 7 with 6 is 42. 6x plus 5 square, 3x minus 1 cube. Just keep on copying them. And this would be 3x plus 1. And that is the end of the derivative of the original function.